Hello, what's up YouTube? This is Mainak and today we will design a building using the response vector method, and I have updated the notes also, which I'll share with you, and I'll also share the stat file with you so that you can easily do the load combination and other things. So this is a very simple model. This is a ground floor only building, and we're going to apply the response vector method, and also we're going to see the final results of this using RCDC or the STAAD Advanced Material Designer. So let's get started. See here, and first of all I'll just insert the coordinates here, and we'll just insert the coordinates. And as you know, for before making the coordinate in STAAD, if you look in the top view, the coordinate system kind of looks like this. And if you look in this direction, this is actually the x direction, a positive x direction. And if you look, copy this, in this particular direction, this is the positive z or positive z, whatever you call it, positive z direction. And here from here we can mark the coordinates like this very easily using the center line. So if the column changes, the center line will change, but this minor change will not affect the results that much, so we're fine with that. Okay. So this stat does everything in meters, so this is 4.2 meters. By the way, if you are just new to the already know the modeling part, you can just skip to the part in the video where the modeling is complete. If possible, I'll mark it in the description. Okay, so 4.2 plus 4.2, it will be 8.4 here. And I'll just copy this. And but it's better that if you can practice this whole plan along with me, so that you can see the z coordinate will be 4.4. So I'll just do it here so that you have a practical idea of how to make this particular building. A lot of guys are commenting me and mailed me that they have years of experience in civil engineering and they've executed a lot of projects, and they want some they want to know how to make the structural drawings. So you can practice along with me like this, just to get better and have some confidence. So once this is done, I always prefer to just do an Excel and copy the coordinates in the Excel there. As you can see, I have already done this before. Okay, so what you do, we start a serial number xyz. It's important to copy the serial number as well. Here Ctrl+C to copy this, and click here in the notes part, and Ctrl+V to paste it here. So once the notes are there, we go to the view and click here and go to the top view, and then we can join it using the geometry option and add beams option. So we just join this nice and good, left click and left click, and then left click, and to join the vertical elements. So we usually for complicated models also you go with the same order, and left to right there is a horizontal, then the vertical. And if you mess up, like if I just put it here, that this option will come, just click on no and then put it in the nodes here. Okay, so then I'll go to select and go to the node cursor and then select all the nodes here. You can also use the Ctrl+A option, and I'll go to view and I'll just go to the isometric view and go to geometry and use the translation repeat in the y direction to make my foundation level. So I'll give my foundation level at minus 1.95 meter. I'll take 1.5 meter as the foundation depth and 0.45 as the plane height, and use the link step options and click on OK. So my foundation part is ready. Now I press Shift+1 to go to the front view, and in the front view we'll use this option. By the way, also go to the front view using this option. Go to view and using this option. This is a shortcut, and you'll go to geometry and use the translation repeat option in the y direction, and we'll do the translation repeat here. 3 meters is the height here, and then click on link steps and then click on OK. So we'll go to view and isometric view. Okay, so I've not discovered any shortcut for the isometric view. If I find, then I'll use it. Okay, if you know guys know, then let me know in the comments. So this is the view here, and then we'll go to the properties. Now define the properties here. We'll go to define and refine the rectangle. So for the columns, we'll go with a property of 400 into 400. Click on add. I think this was added by mistake, so I'll delete this. This is a property for the column, and now we'll define another property for the beams here. Rectangle for the plane beam 250 into 350 will be defined, and for the roof beam 300 into 450 will be defined. We'll close this, and first of all, for the columns here we'll go select parallel to Y, assign and yes, and then for the plane beams shift +1, go to front view, select this, assign to select beams, assign and yes, and then 300 into 400 properties, select this and assign to select beams, assign and yes, and then go to view, and this is the thing. And when this is done, we'll just go to the materials here. So you can see by default all the materials are concrete. We are fine with this. Go to specifications now. Now we'll add a specification. This is where our nodes come into play. We'll just open our nodes here. I'll just close this coordinate file, don't need this anymore. So the first thing is the response spectrum, which we are going to do in this particular video. So the response spectrum, what does the IS code say, and how we can generalize this? Response spectrum is a representation of the maximum for responses of a spectrum of an idealized single degree of freedom system having different natural periods but having the same damping. So you're considering the same damping under the action of the same earthquake ground motion at their bases. The response referred to here can be maximum absolute acceleration, maximum relative velocity, or the maximum relative displacement. Okay, so acceleration, so the response of an earthquake is measured in terms of acceleration, velocity and displacement. So you can easily relate, if those who are good in physics, or have basic idea of physics, that displacement, velocity and acceleration are related by the differential functions. Double differentiate and you get the acceleration, single differentiate to get the velocity. Like this, these are all related. So these are the responses which we get in the earthquake response. So these are mean by the response of an earthquake, and we know that the earthquake simple definition is equals to VB, which is the base shear, into the seismic weight of the building, and we know our seismic weight also, which is the dead load plus percentage of the live load in the building. We know the seismic weight and the base shear we have to calculate. So that's how what we are doing in the software and applying this force. And after applying this force, we are designing the software, designing the model of our software in such a way that the model building is able to resist those forces. So next is the first step, which you will get in the nodes, which you can download for free, and ensure that the modeling of the structure is complete. So the modeling of the structure is almost complete here. Okay, and ensure that the earthquake load is provided into. Okay, so we'll go into the next step later, but I think the step which we are referring to here is the crack section, which is in step 6. I think I should okay, this let me in step 6. So for as per IS code, in page number 14 of the printed version of the IS 1893 2016, and in page number 14 we'll find for structural analysis the moment of inertia shall be taken as 70% for I gross for columns and 35% I gross for beams in case of RC and masonry structures. So your RC structure here, RCC structure here. So in this we'll take 70% of moment of inertia of columns and 35% of moment of inertia for beams. Why do we do this? Why the code has considered this? We'll discuss further. I don't want to make this video large, but we have to take this for all RCC buildings as per the IS code. So let's do this. So we will just go to beam here, and in the beam we are going to go to the property direction factors. Remember to apply these factors in the X and the Z direction only. That is the lateral, that is equal to call the horizontal or the lateral directions, not in the vertical direction. So 0.7 for the columns here, and just add this, and also go next property direction factors. We'll just go with 0.35. Just drop in a 0.35 here, 0.35 here, and click on add again, and then go to select here and parallel to Y and assign and yes, and also select this and parallel to X and parallel to Z, and then assign this. Nice and good. Now we need to use the diaphragm also, but for using the diaphragm we should ensure in the stat editor or the stat command file that the diaphragm is defined after the reference load or the mass reference load is defined. Okay, so we can change this thing in the editor later, so we're not concerned about that. So we'll simply assign the our diaphragm. So for assigning the diaphragm, you want to go to select and go to node cursor and see the coordinate of this node. So this is x is 0, and here also sorry, y, the vertical direction, is the height. Okay, so y is the height, so y is 0 here, and in this also y is 3. So I'll apply two diaphragms, one in 0 level and one in 3 level. Okay, so just go to node here and flow diaphragm option. Those who are using the earlier version, they can use the master slave options, but now we have the flow diaphragm options here. So define flow range, so make sure this is selected. Okay, define flow range and select node is selected, and in the height is 0, and we'll let this program calculate the master node and click on add here. So if you add the master slave, we can see the information after we apply, but in case of diaphragm we cannot see. In this my version, I think in the latest versions we can see. So and then we'll go here another for the same thing, flow diaphragm, and diaphragm number 2 obviously define flow range here and calculate, and height will be of 3 meters, and click on add. Okay, so we'll select this here for the 0, shift +1 to go to the front view, select the node cursor is there, otherwise just go to select and select the node cursor and assign to selected nodes, assign, and yes, select this and select this. So we have assigned our diaphragms. Now we can see the difference when you are using the master slave option. If you press shift +L, then this is visible, but just here this is not visible. Okay, so this let me know in the updated versions this is visible or not. Okay, so so we're done with the materials, we're done with the specifications, right? Okay, but we have to remember that the diaphragm should be defined after the reference mass, otherwise this the problem will give error. So we'll fix this later in the command file after giving the mass source. So then we go to supports. Obviously we the function of assigning supports is to denote the connection between the column and the footing, as far as I know. Okay, if there is anything else, please let me know in the comments, because as I told, this is a community to learn, for you guys to learn, and also for me to learn, because there is no end to learning. That is what I believe in sharing knowledge. Okay, so we'll give the GAN later. So just create this fix support here, and shift plus control plus shift plus click here, and then shift +1, and then we'll go here and click on the side and yes. Okay, and then we'll go to view, and then we'll just select this. This is the thing, and then we'll go to loading, and then this is the case here. We'll go to loading. So support part is over, then we'll go to loading. So I'm going serial by, so that this is my method. I'm going serial by so that I can remember all of the things. So firstly, I want to define the reference load. I can also define the wind load also, but I want to define the reference mass load first for the dead load and the live load. But for defining the reference load, I need a dead load and the live load. So I will have to adjust this later in the STAAD editor. So I'll define the wind load, because nothing is required to define the wind load. By the way, my method of wind load application is not perfect. So you can refer to other methods as well, but so this, I'll tell you which part is perfect and which part is not. And I'm also using the version where we don't have the wind load generator as per the IS code, so I'm using an Excel file. Okay, so I'll just click on add here, and wind load is added, and we'll add this wind load here. So I cannot go by any of this code. This is not IS codes. In the next version we'll find the IS code, so we'll have less problems. And then I'll go the height and the intensity here. So I'm going to use an Excel sheet. Unfortunately, I cannot share this Excel sheet with you guys. I'll make another Excel sheet in some time, which I could share with you. Okay, so this is the Excel sheet here, and basic wind speed, terrain category. You can see all of these are given, page number is given. You can take the screenshot, and this is allowed, but you can make this. When I perfectly do the wind load, then I'll upload this and share with you guys. That's my plan. So let's not discuss the these things further. All these things, page numbers are given in the in the code here, in this particular thing here. You can just study this. I'll make a separate video on this. I promise. Okay. So then the height is, just ignore this. The height is 3 meters, and the terrain and category K2 for in page number 11 up to height of 10, everything is 1. So this is 1, and this will find the PD max. So everything formula is given in the code. You can find out and calculate this. And so we'll give out for 3, the intensity is 1.75. So that's what we'll give here in the STAAD here for height 3. It is 1.75. If this is a multi-story building, then we'll give multiple things here. Add. So up to this much portion is accurate as per the code. The CP and CPI values I'll not apply accurately. I'll be very honest with you. No, the reason I'll just tell you later. Okay. So the wind load is applied. And then only the wind definition has been applied, wind load has not been applied. Then we'll go to the seismic definitions. Okay. And we'll add the seismic load part. Okay. So here we'll go with this seismic load 2016 and then click on generate. And the seismic load part, as far as I know, and to best of my knowledge, is perfect. Okay, so you guys can rely on that. However, even if you find something which is additional, you can let me know in the comment section. Okay, so we're going with RC special moment resisting frames here, and we're going with all other buildings here, and we're going with medium soil, and we're going with all other buildings. So everything I'll explain, and we are also letting the program calculate, or it will just calculate this anyway. Okay, so going back to our nodes here. Okay, so this wind thing is not required now. Going back to our nodes. So now okay, ensure that this earthquake load is provided in two lateral directions for normal conditions, and for 3 lateral direction for zone 4 and zone 5. So if you go to the code page number 8, you will find the design vertical earthquake effects. Most of you know that the earthquake occurs in the horizontal or the lateral direction, so we apply in only these 2 directions, and in most of the videos you'll find the load is applied in 2 directions only. But the code says in seismic zone 4 and 5, you will find that we have to consider the vertical effects of the earthquake as well. So the effects of the vertical earthquake shaking will be considered in the following conditions. Structure is this is a screenshot of the code, by the way. Structure is located in the seismic zone 4 or seismic zone 5. Structure has a plan irregularity or vertical irregularity. Structure is rested on soft soil, means pretty much in all soils conditions which you have to go with pile, means there are soft soil. So you have to go with this vertical earthquake effects. In bridges and long span, basically any span above 7 meter I consider as long span. You can correct me on that. So for that also you have to go with this vertical earthquake effect consideration. And the structure has large overhangs, that is, if it's large cantilever system. For large cantilever system, I mean, I think if it's more than 3 meter any cantilever is there, then it's large overhang. So then you have to go with this vertical effects. So then you calculate the time period of the building, or you can also let the software calculate. So as per the IS 1893/2016, part 1 plus 7.6.2 and time period can be calculated using this formula. So there are other formulas as well. The first formula is for the RC frames without any masonry infills, without any walls. So the correct way, as per best of my knowledge, is this one. And I also asked many of the professors, they've also recommended using this formula, because the formula which most people use is the RC moment resisting frame without any masonry infills, which I also used earlier in my earlier videos. That was wrong, because we are using masonry infills. Masonry infills means walls. So the best condition which you can apply for normal buildings with columns, beams, and masonry, any kind of masonry, it is this particular formula: 0.09 h divided by root over d, and h is the height of the building, and d is the base dimension of the consideration. So if you're considering in the x direction, so you'll consider the value of the x, and if you're considering the z direction, you'll consider the value of the z. So obviously our x direction will be here, this will be 8.4, and our y direction will be 4.4. So but this is the center line. Obviously this is not accurate, this can be more. So 4.4 is 4.4 or 4.5. Okay, building height is 3 meter, and so 3 meter is accurate here, and here it will be 8.4, and this will be 4.4, and this will be approximately near to this values, 0.1 and 0.13. This will be little bit less than 0.1, but I've considered 0.1 itself, because this becomes 0.09 something. 079 something. So I'm just consider 0.1 for this time period. So and then we'll ensure the seismic mass source is provided. So we know this, we've talked a lot about seismic mass source in the earlier videos. For those who are new, seismic mass source is the weight of a floor divided by acceleration due to gravity. That we know. The mass of a structure, you can find the thing here. What is the weight? So seismic weight divided by gravity is the mass. So if you know the weight, then everything will be okay. So seismic weight is the sum of the dead load of the floor plus appropriate contributions of the weight of columns. These all is the dead load. Okay, these are self weight. These are talking about self weight. Any other permanent elements or stories of they are self weight. Floor finishes and services. Floor finish comes under dead load. Okay, and appropriate amounts of imposed load. So translation, if you just say this in English, this means dead load plus a particular percentage of live load. So you'll find the particular percentage of live load which you have to take in table number 10. Okay, the seismic weight of the floor. Okay, table number 10, you can see up to 3, 25% live load will be taken, and more than 3, 50% live load will be taken. Also, there is another code that I'm not included in this. I should include that. That for the terrace portion, the live load contribution need not be taken in the in the seismic weight. So that also I think I should update this notes. In the next video I promise to update this. So then you have to add the diaphragm, which you've already added. The diaphragm must be placed after the reference load, which will create now in the STAAD command file. The diaphragm definition can be rigid or flexible. We have defined rigid diaphragm, so I have not told you then why we have defined rigid diaphragm. So you can see this in page number 23 of the code. Please study this, and I'll tell you the just very basic version of when to consider the diaphragm flexible or when to consider this rigid. So in normal condition, you consider diaphragm to be rigid. Okay, and if you have your slab has openings, and by the way, that portion you'll find in the vertical or horizontal irregularities table number 6, I think you'll find that. So then you can consider diaphragm as flexible. I think if you have more than 50% of the cutout area of a particular slab, and also if this structure follows this particular clause. So you will not know this until the analysis. After the analysis only you can find this, that the deformation is 1.2 times more than the average displacement of the entire diaphragm. So in normal buildings you will not find this. In in irregular buildings you might find this, or even if there is large spans you will might find this. So basically, if you have plan irregularity or vertical or horizontal irregularity, you might find this. So after checking, then you need to assign the diaphragm as flexible. Okay, but in normal condition we consider the diaphragm as rigid to start the analysis anyway. So then you have to add the crack section property. We have already defined this, and then you have to define the response spectrum model. So we'll just come to this later. Let's get back to the model creation. So okay, I think we should also do this response spectrum models, and we will consider the moment resisting frames, RC SMRF. So we are considering the ductile detailing. So we are considering the special moment resisting frame with a response direction factor of 5, and we have 3 classes of the importance factor. There is the important buildings, normal residential buildings with 200 or more occupancy, and all the other buildings. So this is a toilet block. So we are considering only important factor of 1. Otherwise, we could consider an importance factor of more than 1. So seismic zone factor, our structure is in zone 5, so we are considering the seismic zone factor of zone 0.36. Damping is always 5% as per our IS code, and then consider AH, or the acceleration in each direction as per the IS code. So for the AH, as you can see, page number 9, you need a particular function, that is the SA by G. So the SA by G depends on the time period actually, as you can see in this table. So in response spectrum method, SA by G depends on the time period. So for medium stiffness, our cell is medium. So medium stiffness we're considering here. If you have pile, mostly you'll find a soft soil. So we'll go with this formula. So SA by G, if the time period lies between 0.1 to 0.55, then it is 2.5. So or both is 0.1 and 0.13 in X and Z respectively. So we're going with this 2.5. So if we just put all the values here, and for the directions we have to calculate this, and we will find this. Okay, and for the vertical direction, this formula has to be used. Clause number 6.4.6, page number 14, and this is just multiplied this the earlier value by 2 by 3. You will get the value here. Okay, and let us also calculate this value, which we'll use later. Okay, so z by 2 is equals to 0.36 by 2. That 0.36 is zone factor, so 0.18, and 0.18 into SA by G is 2.5 for the both the x and the z direction, and divided by R by I. R is 5, response direction factor 5, and divided by 1. So 5 by 1 is importance factor is 1. So this is okay. So we'll just calculate this value here, and this is 0.18 into 2.5, enter, divide by 5, this is 0.09. So this is equals to 0.09, and this is AH in the x and the z direction, and for the vertical direction, okay, and this will be multiplied to 2 by 3. So this is AH, x and z, both are the same here, and for AHV actually this will be 0.09 multiplied by 2 by 3 as per this code buildings and 183 part 1. So 2 by 3 is equal to 0.67. so if we just do 0.667 into 0.09, it will be around 0.06. So 0.06. so the AH, we know that the base shear into AH, so we'll take 60 actually 60% of the seismic weight here, and 90% of the seismic weight here. So this will take, and sorry, I'll just told the definition a little bit wrong here. So the base shear is equals to AH into the seismic weight. So AH will decide the magnitude of the seismic weight which we'll consider. So we are considering 6% of seismic weight here, and we're considering 9% of the seismic weight here. So VB, the base shear is equals to AH into W. Let me just quickly find this thing here. So you can find this here. You can also made this earlier video, and PPT link and shared in that particular video. This is clause 7.6.1, base shear equals to AH into W. Okay, so I told this wrong in the starting of the video. Sorry for that. And okay, so now hopefully you can get the corrected version of this. Also, I recommend watching this video. If you haven't watched this, I'll just put the link in the description or in a timestamp. Okay, so here now. So once this is done, then you can also consider the eccentricity. This is the advanced. So the eccentricity, you can consider the response spectrum 0.15 ESI, that is static eccentricity, and 0.05 BI. And this will not consider in this for this particular video, but because I'm not consider actually the load combinations for that. So we'll consider this in later video. But I've heard I need to do some research for this, because I have seen in some posts that this is automatically calculated by STAAD.Pro. So we know about this. Let me know in the comments whether this is automatically calculated by STAAD.Pro. We have to insert it, and then we have to insert the load combination as per the seismic code. So we all know that 1.5 DL plus LL plus in a particular direction, but if we apply for two direction, then these combinations, that is ELX plus 0.3 LY, we have to include in a load combination. So load combinations will look like this. If we apply in two directions, 1.2 DL plus LL plus ELX full in X direction, and 0.3% in Y direction, like this. And if you apply in three direction, then it will look like this, full in X direction and 0.3% in X and Y and Z directions respectively. So all these load combinations, I have prepared a file for you for three direction, and you can use this, and you can also convert this into two direction also by deleting some of the loads. That's as per you, and you can use this. So when I share the chat file, you can just copy and paste those, but the order has to, the loads which will apply has to be the same as me, otherwise this will work. Run the analysis and display analysis results, and after we then display the analysis results, we check that the number of modes to be considered is at least 90% in the first three modes, and at least 65% in the each plan direction. So we have to check as per this 7.7.5.2 page number 24, and another thing, one is the page number 17 here, this in table number 6 of the plan irregularity, you'll find this. And another thing which we'll not discuss in this particular video, but you should look, and I also will do some research on this, because again, adjusting when you apply the response spectrum load, there is a scale, and we need to adjust the scale of the response spectrum load as per the IS code, that if the VV calculated using the dynamic method is less than the VV calculated using the static method, then we have to apply a multiplication factor. That is basically will multiply the static load by the dynamic static base shear by the dynamic base shear, and then apply it as a scale in the STAAD.Pro software. But I have seen some posts in which they have written the software automatically calculates this. So I'll do some research on this, and also then find out what is the actual thing which we should do. That's why I kept it under advanced, which I should do in the previous video, the upcoming videos, and also you guys can do some research and let me know in the comment section which is the accurate thing to do. Okay, so those who have watched the video till now, it's obviously we're very passionate about this, so let's continue, and hopefully that we can complete this building. So we have clarified all this, and in the extraction this is 0.1 and this is 0.13, and then click on generate, and then click on add. Close this. Load case details, and in the load case details I'll use a previous stat file just as a shortcut here. This is the plan project number 9, right? So yeah, I'll use as a shortcut here, just to, because you can use my stat file because I don't want to redo the steps here. Dead load, live load, and I'll copy up to this. Should I copy the response spectrum as well? Should I copy the wind load as well? Okay, I'll not copy this truss load. Just copy up to this wind load for now. Everything. I'm not sure whether I should do that or I should tell you properly. Okay, I should do that. I think those of you which have watched this already advanced users. So after this load, we'll just apply this, and you can use my stat file to apply these loads here. Okay, so basically what we're doing is applying the seismic loads in the 3 direction, and the dead load and the live load, and we'll adjust everything as per our building here. Okay, and explain everything. So now seismic load in this 3 direction, this is okay. I don't think we need to touch this. Okay, seismic load would apply create seismic load, and then you have to apply this in the seismic loads in the X, Y, and Z direction as a factor. You can do that in the software itself. Okay, this is done. And the dead load, self weight -1 applied, and 15 is the weight of the walls which we have applied here, and Y15, I think this is 20 is the unit weight of the wall and plaster together, and then 3 meters, and then 0.25 is the 15, like this. So I have considered this in the in the top as well. In the top you can consider separate weight of the parapet wall if you want. I've considered this as well. Okay, I'm telling you live load of 2 in only in the ground floor. Live load you did not apply in the ground floor, but since this is only a single story building, I had applied here. Also you can apply live load here as well. Okay, in this range as well. So you can do that. And response spectrum, now we'll edit this response spectrum load. So these are the things CQC we have taken. The spacing is different, then software will suggest you to go by CSM. Then you can change this. You have to first select IS 1893-2016 if you want to apply here, then select the medium style, and then when you click here, then this option appears. Only thing you need to use is this. And if you go to the advanced method, you can also consider the eccentricity, so which will not do in this particular video. And if you want to consider scale, you can also do it here, which will not do in this particular video. Okay, because I doubt that the software automatically calculates the eccentricity and the scale also. Okay, so we'll skip this part, and we've already calculated in our notes that the X and Z direction, where is it? Yeah, in the X and the Z direction our AH is 0.09, and in the vertical direction it is 0.06. So just clicked on this. Okay, so in the vertical direction, if you see here, this will be 0.06, and in the next direction also this will be 0.09. Here you can see this 0.09. Okay, so you can apply all this in the software itself, no need to copy a editor file. Now I'll need to change this wind load here. I think these ranges are well defined. Okay, the ranges are well defined. So what I am doing is, and why I told the window application is not 100% accurate, but this method many people follow, but this is not like 100% accurate. I'll call it, this is the related lazy method. So what happens is that we have calculated everything, but for the wind load we have two factors, that is the CPE and the CPI. So the CPI, I need to open this again on the desktop just to mention this. This one. So the CPI, as you can see, the CPI value is filed in page number 14 of the code. So for this is there are three CPI values, as there is point plus minus 0.2, plus minus 0.7, and plus minus 0.5. Okay, for these three different conditions. For normal condition of 2, and if there is more opening, then is point plus minus 0.5, and there is even more openings, there is even more open, even more windows or openings, then it is plus 0.7. So in a normal condition of normal doors and windows, you will have to take CPI as 0.2, and then the CPE, there is a table in page number 16. We have to calculate the CPE as per that, and then suppose the CPE is 0.8 for the windward direction in the windward phase. So this is the building, so this is the windward axis. If we are considering the wind along this direction, so this is the windward face, this is the leeward face, and these are the two side faces. So side faces, these are all usually the same, values are given. So suppose in the windward face CP is 0.7, then we have to calculate the maximum value. How we can calculate the maximum value? If this is plus 0.7, then you have to add plus 0.2, and if it is minus 0.7, then you have to subtract minus 0.2. So the thing is, we have to get the maximum value, and then the maximum value we have to apply in all the directions. So basically what we'll get is, we have to apply the wind load in for positive x direction. There will be one load case in which the wind will be applied in all the four directions here. Let me just show you here. Let's focus for this. If this is considered as the positive x direction and wind load, and I have to apply the as factors in all the four directions here, and define the ranges of the coordinates here. So the ranges will be the same here for a particular phase. Okay, for this phase the range will be same, for this phase the range will be same. Like this we have to apply for positive x direction, and like this I have to apply for negative x directions, and like this we have to apply for the, now if the wind is along this direction also, then this becomes leeward phase, windward phase, then this becomes leeward phase, and these two become side phases. So for all the four directions there will be total of, for the x there will be 2, this there will be 2, for this also there will be 2. So total there will be 4 wind load cases, plus x, minus x, plus z, minus z we have to apply. So this is a long process, so I'll make a separate video for this, but I've seen that many people are using this method, and I'll not call this method 100% wrong, because all the wind intensity has been calculated accurately, and in most cases the maximum CPU which you'll get is 1. So if you apply the loads in all the four directions using a factor of 1, which you have done in this particular method, that is windward phase 1, if you apply everywhere, so the results are pretty much this on the safer side. Okay, it is, you can call this a little bit conservative. The structure will be designed for a little bit over designed, but not under designed, to the best of my knowledge. So if you are in a hurry, then you can use this method, but if your structure is going through a proper vetting process, then you can't follow this process. Okay, you have to apply everything accurately. So I'll make a video on this particular topic. So just I'm letting you know that this is not perfect, so that you don't follow this when perfection is required. Okay, but the earthquake part is perfect as to the best of the knowledge, and I'm trying to, if there are any flaws, I'm trying to fix that and make it more perfect with the help of you guys, obviously. Okay, so this response spectrum load has been applied, and when this response spectrum load is, you can just apply using the basic load cases, like you can add this, and you can just code the primary load, primary, and you can add this as seismic weight. Okay, and you can add the response spectrum load normally as well, and after you add the particular load, and you can just go to add, and you can go to response spectra, and you can apply it. Don't need to copy my file. Okay, so I'm just showing you. So once you have done gone through this particular loading part, next thing is we need to do some parts of the definitions. So we'll go to our beloved editor or the command file. I keep on saying editor because earlier it was called the editor file, now it's the command file. So what does the table number 10 says? The seismic weight is the full dead load and the percentage of the live load here. Okay. So first of all, now we'll go to the reference load and we'll add a mass source here. So this will be obviously mass, and I'll call it the mass. Okay. Close this. I'll use the editor, sorry, command file to do this. Full dead load and a percentage of the live load here. So the dead load starts from here. We'll copy this. We'll see where the seismic mass is applied here. This is here, and define reference load. Before this, in this you have to define the reference load, so we'll paste it between. So first of all, I'll zoom in because to help you guys. This will be in y direction, and this will be, I'll make this, copy this and apply it in all the three directions. Caps lock is on the X. This will be Z. Member load, we don't need to change the member weight because you're in reference load. We don't need to change it to member weight, but if you apply the same load, you remove the sign and apply this in all the directions, all the three directions here. So Y is applied, so I'm just using X above it, and here we'll use Z. Okay, load type LL we don't require because there is only a single load. Flow load here will be 25%, 0.5, and this will be applied in all the three direction. If you have floor finish also, we have to apply that also. So X, Y, and Z. Reference load has been applied, and now we need to define this reference load before the diaphragm. Okay, Ctrl plus X, and before the diaphragm and also before the definition of this mass source also, seismic mass source. So where this is not relevant here, and we're going below, I'll make this as 25,123,000, and then this is correct version, and okay, I'll define the diaphragm here. So it's seismic mass source here, and the supports I need to define before the supports need to be defined before the reference load. Okay, so this is also a thing you have to ensure. Hopefully there won't be any errors, let's hope that. And let's also define the load combinations as per our thing, service load combinations, and this load combinations here. So if you use the STAAD editor for the default load combinations, then you will not get this. Okay. By the way, the wind load part I have used and made using this default STAAD editor files, and then I deleted the portions which I don't want. So this is okay for the wind load which you applied, but if you want to go for the perfect process which I just mentioned, then you have to create use the STAAD. You can use the STAAD file to create the wind load. So wind load part is perfect with the STAAD command file to calculate the load combinations and delete the earthquake load combinations, and keep these earthquake load combinations and only use the wind load combination. So you can do that. I think I'll make a separate video when I advance to this particular topic. Till then you have to do it yourself if you want to do it. Okay, so just close this part. Let's see if we have any error. I think we will have error. Why I'm feeling this way? No, we haven't everything. Run analysis. Might get some errors. Okay, 26 errors. Thing is, if I okay, this error, I like this error. Yeah, because this means that I have not inserted the properties of a particular section, so I'm fine with this. So this is okay, this is okay, this is okay. utilities, where was this? There was an option of a missing file. I think we'll go to select. Yeah, select property name, missing property, missing property, missing property. There is no missing property. Missing elasticity. There is no missing elasticity. Missing density. Let me see. Okay, let me try and just remove all the properties, because I think I messed up something in the stat editor file. I should only change this. Let me just redefine this, hopefully. Concrete FC 2000, that's what I defined. Let's redefine this. Properties, if this solve this problem. Let's just take a default section first, 0.4 into 0.4, and apply it everywhere. Just to check. Which member section property has not been applied? I'm seeing all the members here. Okay, let me just pause. I think. Okay, back to the editor file. I think this portion was plus x should be before this. I'm just using the reference of a file here, and define material. So after and define material, then the member properties are there. Okay, so after and define material, then this should be there. Okay, I think this will solve this problem. So I think when we have applied the reference load, I have just messed this up. So now this is fine. It's fine. Analysis is now complete, so I'll just fix the properties now to the best of my knowledge. Here this 400 400 is okay, and we'll also add two more sections here, rectangle, and it is 0.25 into 0.35 was there for the plane beam, and 0.3 into 0.45 was for the row beam. So this one selected, shift +1, select, and then shift +1, select this, and then assign to selected beams, assign, and yes, and for this one select this, assign to selected beams, assign, and yes. So not considered the flow load here, because there will be a truss of this, a steel truss of this. So I'll tell you in a separate video how to make the steel truss design. We'll do in ETABS, and then we'll put the loads here. So we'll do that. So let's do this without adding the load of the steel truss here. And once this is done, we'll just do the I think do the design directly. Okay, so we'll go to the analysis and design. Let's finish the design commands. Select concrete here and select the parameters here. We only need to select the minimum parameters which are there. So we'll go with compressive strength of concrete, strength of main reinforcement, and I want to include the minimum main here, minimum main, because these three things are important as per me. Okay, and also define the three commands, define add beams, add columns. Not designing any slabs here. First of all, I'll make two groups here. Select first of all, go to this view, and then go to select parallel to X and parallel to Z, and I'll do this as a group, Ctrl+G, shift plus G, sorry, control plus G, is control plus G. So this will be a beam, okay, and names will be all beams in one group. Okay, blank characters now. So beam, okay, and associate, okay, just click and then I'll just highlight and then check. Okay, so this is okay. Now go to select and parallel to Y. This will be a new group. We'll create this as column. Let's let the full name, beam, okay, associate, and then just for checking, highlight. Okay, this is done. Now it will be fun to I'm trying this for the first time. It will be fun to, I think, assign all these things, parameters. So define parameters first of all. I selected those parameters here. Okay, why concrete? Define parameters. Design beam. Let's do this first. Design beam and assign to select group beam. Okay, assign this like this. Select group column. Okay, assign. Okay, fun. Okay, you have to do this portion again. What was this? FC FI main and then minimum main done. Okay, define parameters FC 25123 M25 FI main FE 500 and minimum main I'll go with 60. Right. Now find this here. This I'll assign to view, signed and yes. This I'll assign to view, signed and yes. And for this I'll assign in two parts. First I'll apply to the beam, and also I'll also define minimum main of 16 once again, so that I can assign for the this one was for the beams, right? This one will follow with the columns. This one for the column. Okay, fine, done. Now we'll run the analysis. Analysis now complete. Response spectrum method design you can see here, and effects also you can study. Let's go with the RCDC to just design this. I'm just I'll go first for the column design, except you can fill this out. Column, firstly go to level data and change this. In our case it is 500 and cover is 40 for the columns. Go to settings and go to design settings. If you, for large buildings, I'd recommend using this. For small buildings like this, if you consider ductile drilling, the design is a little bit on the higher side, so you can avoid this as well. Okay, so for this I will avoid this for now and just go with OK. By the way, you if there is a vetting, always include this ductile drilling. So I'm just getting a proper example by including this. Go to basic load cases and you need to define these basic load cases here. Very easy. Very easy. We'll add from analysis because we will add the special load combinations there as per the IS code. And you can go to settings, and you can reinforcement settings. You can just set the minimum. I prefer to do the 16. Yep. So this is the load here, and then you can obviously generate the output. You can generate the reports. You can generate the schedules here like this. So I'll not do this here particularly. Then you can go directly to the footing design. Please save the project. I have to save the project, Ctrl+S, and save the project here. So you already know you can generate the reports and drawings here. So you go to the footing design here. Since the video is large, I don't want to just generate the drawings. You already know that how to do that. If you don't know, you can just click and find out the suspense. So here, first of all, let's save this file. Okay, I'll save it later. So we'll go to settings and go to our general settings here, and in this just FE 500, and then take the SBC here. SBC is 130 here, and click on OK, and then yeah, we're good, and let's just design. So after the sizing load combination, this are the earlier things are imported from this. So if you do the footing design directly from the column design, then the advantage is you don't have to include this load. For the beam, you have to do it anyway. And for the sizing, add for template regular structure, this was sizing. So it will get the you will get the column or the footing size. So once you get the footing sizes here, and you can just save the file and proceed. Okay, and to just generate save this layout file, and also generate the reports like the text schedule, the vertical schedule for this in the AutoCAD file. You can just copy paste here, and also if you want to generate the drawings here, detailed drawings also, let's go for a particular footing. You can generate the detailed drawings here for the footings as well. Okay, sections also. So all the other things, wheel of quantities, you can just check. Okay, so I'll close this one, not save this, and we'll go for the beam part here. So now the STAAD file will open, and we'll now go for the beam design. We'll show you one plain beam or roof beam. Let's go for the roof beam design. So just fill up this data. Beam, now plain beam is 0 and roof beam is 3. So we'll go to the roof beam here, roof beam design. So you have to, when you go for the beam also, you have to again define the load combinations here. First of all, I'll just fill the general details. I want here M25 and FE 500, and minimum bar I want here 16. Okay, 16. Let's go 16. Okay. Ductile detailing has been considered, I think. Yeah. Okay, not just consider this ductile detailing. For if you want, you'll have to, if you want to go on the safer side, just define the load combination. Very easy. So if you watched this video till now, just let me know in the comment section, because I love to read your comments, and this gives me the encouragement to make videos like this, because this mainly I'm doing this the source of passion. There's no other thing as of date. So love to read your comments, and also your suggestions if I'm doing anything wrong, and I learn many things from you. And I love criticism, because criticism helps these things, and corrections, criticisms, I love this. So just let me know in the comments. So this is the file 316, and then obviously you can save the report, take the schedules, and generate the drawings. So if you can do everything, you can also go for this this option of quick elevation. You can just go and see the elevation of this particular beam. So there are various features are there. So hope this video helps. So we'll not end this video right now. Love you guys. Bye bye.